Cool. And back to here. All right, so you can't do it. By the goofy little diagram in the middle there, things that you get inspected. So if you're making things, Station A's got something, Station B's got something, A shares with B, B shares with C, A goes to C. I know it kind of looks like a little construction management stuff, but generally you're inspecting on the outside is your first go. So the way to catch more errors to find out what's going on is to put inspection stations in the middle between stations. Go away. Don't touch the screen and I'll be better off. So if I got 1,000 parts I'm running through, basically I want to inspect in 4 places in the middle of it and then inspect it once out here. So I'm going to need 5 people to do inspection. But I'm going to only sample certain numbers of pieces out of that. So if there's an N of 1,000, so the number of pieces that I'm making that I have to measure are 1,000, I only want to have to pull 25% of them. Why pull all 1,000? Because I already know 100% sampling doesn't work well. Okay, so that's what this comes down to. Put in terms of I didn't ask this question the other day. I know you're civil now. Construction management, industrial tech management, construction management. What do you two? Construction. Okay. So I'm going to try and gear this towards civil stuff, but I just want to make sure I wasn't talking to somebody who had no idea what I'm talking about. Because I can do that really easily. But if I'm going to pour concrete, okay, and back off every truck, we do a slump test, right? Why? Because we want to verify what the concrete is that's going into that job. And I record that data. That's 100% sampling, but you're not doing anything other than recording it so you know what the record was in there. But let's say we're worried about, let's say Potsdam, no, it's not Potsdam, Upstone mixes the concrete for us. We're getting a little worried about them. How many of those samples do I actually have to pull to verify the concrete's right? So I'm going to mix, not the slump test so much, I'm going to go mix cylinders off the back of that truck. And how many of those do I need to do if I'm going to have, let's say we got 16 or 20 trucks coming in that day. That's what you're going to do statistical sampling of, so I don't have to measure every concrete cylinder. Okay. Could you? Sure. But you really don't know, and is it really worth your time and money? Okay, that being said. Okay. What we're really trying to get to is this. The root cause of the error. So as we're trying to measure things, we want to know what the mistake was. We don't want to know how many mistakes there were. What caused the mistake? Okay. Did they not put enough cement to water ratio in? Was it a particular driver that showed up and didn't add enough water in the back of the truck when we were getting ready to pour? Okay. By the way, the dumbest thing you can do, you all know that concrete has a lifespan before it's got to be poured. So if the truck comes wet, we got to get it out of the truck. Okay. If the truck comes dry, where it's just been rotating and mixing and agitating all the way along the road, and they get there and they add the water, relying on the driver to add the right amount of water. Okay. And that's usually the problem. Too much water and we're SOL. Too little water and we're SOL. Okay. So cool on that? All right, I think that's where I got to sampling, why not, process control. Yep, okay, cool, that was that bit. Okay, so a little history, and I'm going to try and keep this as not as dry as humanly possible, but basically, let's add a page here, and view, rolled lines, and I'm going to take you over to the next page. So there's some history to all this and how things have happened. So like all good things, you probably should know why and where. So we are looking at the history of statistical quality control. And it's known as SQC, but it started 1924 at Western Electric. Okay, and there is always a person associated with it. Otherwise, it wouldn't be any real fun in telling you the history of it. Thank you, Jay.
I didn't get it all out. I closed all the valves off, and I'll shut the. But I wanted to see how far you could go with that. You can go all the way to here. Just
Oh, cool. You sure that it?
Shut the thing off. And I'll get it to one more.
Okay. So Walter Shewhart, all right, decided that he really wanted to understand things. So he used control charts. Okay, so basically he was looking at things going, how do I see what happened in the steps and where things went wrong? Okay? So there's an old adage in the world, you can't change something you don't measure. Okay? So Western Electric was the electric utility company. They were making power generation, but things weren't getting the power quite out the right way. And he basically started keeping logs on everybody, which he called a control chart. Funny thing is, we still use the word control charts. Okay? So it is what it is. He's the first guy. Then okay, so World War II came along. We needed a way to make a lot of good things fast and make them right. Okay. Anybody a Bugs Bunny fan? You guys know who Bugs Bunny is? Okay. There's an old one in there that's my favorite. It's the Gremlin and Bugs Bunny fighting over an airplane, and it all starts out with the Gremlin going around trying to explode ordnances. So he's out there with a hammer whacking the nose on a bomb. Okay, Bugs Bunny sees it and thinks it's cool, so he wants to do it. But literally, it's how many bombs were made that would not explode. okay? And they always blame the Gremlin. The Gremlin was this little cool thing. He was like a little B-17 with little wings out of it, yellow, and all kinds of fun things. But cool cartoon. But the reality was he was testing the quality of the bombs. Well, hitting them on the nose of the igniter on a bomb is probably not the way to go about testing a bomb. That's like somebody standing there in a bomb factory going, bang, dud, bang, not a dud. And the one you made just didn't go where it's supposed to go. So we want to make sure things were actually being made right. Okay. So when they made bombs, they knew they were going to go out. So it's how to keep a log of all the things went right. One of the greatest things from World War II was the U.S. Navy and their submarines for the first year or so were attacking Japanese vessels, but the torpedoes would not explode on impact. Well, what's the sense of throwing a torpedo at them if it's just going to go ping and made a dent? So they literally went back and figured out there was a fault inside the torpedo. But according to the Naval Ordnance Center, you can't change that. That's quality. Turned out a few rogue submarine captains decided to take it in their own hands, and then the entire Pacific War fleet decided, oh, guess we should change this. And then it became acceptable. But there's a lot of cases like those torpedoes that didn't work, and somebody had to go figure it out. There's something with an airplane, too. I can't remember exactly what it was. Oh, it's controls on a P-38. It would not respond in combat the way it was supposed to. The controls were too sluggish. And one of the maintenance people out in the Pacific basically said, what if I put a little twist in that cable? And he put a little device that he made in there. But he modified things against orders. And what it turned out to be, the captain that flew that plane was impressed because he actually survived where everybody else prior to him was getting shot down. So how do you measure quality? How do you sample for it? It's somebody looking at the root cause of what was going wrong and see how to fix it. Right? So keeping logs is important. So what Walter did back in the beginning basically moved itself into World War II. Okay. Then came this guy. Sorry, you're going to have to remind me to keep looking over to raise the screen. Okay. 1950. Okay. Enters Juran, Juran. So, you guys are way too young for this. I know this for a fact. So, when I was a kid, everybody wanted a Japanese transistor radio. Okay, it was the coolest thing. Okay, Japanese were really good at manufacturing transistor radios. It all started because Deming and Juran went there to show them how to use the statistical quality control process to make better parts. So literally, you wonder why things made in Japan are so much better? Well, that's the reason. Okay. And hey, Luke, there will be a video on this to watch.
Yeah.
Okay. So these two guys got invited. The dumbest part is the Americans didn't pay attention to the fact they went over there to help them out. And when the world got straightened out, America decided in 1970, 1970s, actually probably late 1970s, Okay, and it sounds kind of dumb. We already knew how to do statistical quality control, and we let it slip. Wasn't a war on. We were making lots of stuff. We were literally selling it to everybody who could afford it. So cars became plentiful. If a bad car happened out of a job on Monday, nobody cared. They fixed it and moved on. Um, it wasn't until the 1970s that someone said, why can't we make better stuff? Why are the Japanese beating us at this? So we really have to do something about this. So that's about the time the US woke up and went, hey, there's something to the logic and the theory that they were telling the Japanese. Okay. And to this day, the Japanese manufacturing, hands down, is still a superpower in making things. Okay. All right. I'm now going to give you written material on Deming, but I just want to tell you about him. There's nothing in his personal history that I'm going to test you on. He was born in 1900. This guy's older than the hills. In 1950, he was 50 years old. He got a PhD in physics. Not math, physics. Okay. He met Walter Short in 1930 and understood what he was doing. In 1940 census, he came up with a method of doing sampling for the census. Prior to that, they were going, see here how many people live in the household? And they'd go house by house by house by house by house and try to do it. Well, when the census was created by the federal government, there wasn't a whole lot of people in America. Okay? 1940s, things got a little more hairy, and we also didn't have as many people standing around twiddling their thumbs. We had a bunch of people fighting the war. So how do we sample? So he came up with a process for that. So that's where Deming started his statistical process control. Okay. All right. He went to Japan in actually 1947, 1950. When he was there, he trained 20,000 people in how to do things statistically and come up with the right numbers. He also created, for the best improvement, the Deming Award. So you'll see stuff out there that Edward Deming, W. Edward Deming, became the prize for that. Okay, and his famous line was, I'll write this down. In 1979, NBC broadcasted if Japan can, why can't we? And that became an NBC report that went on the TV. Okay, everybody was caught off guard for doing that. Reality is, there are certain things Deming does to make this possible. Okay, and this fits no matter what discipline you're in or what career. These are Deming's approaches. Okay. 1. So, I review notes, not even on the page. Okay, so number one, if you give somebody the chance to do something and they're not held to accountable standards, they will find the easiest way to make something. Okay? So if I want to make, well, let's pick on Ryan. If I want to make maple syrup, okay, I want to make sure that the sap is gathered at the right time of the year, not the wrong time of the year. If I give it to Ryan and say, go collect me sap, he may decide to do it in the fall, because that's where the nicer weather is, instead of waiting till February when it's cold, okay, which is the wrong day. Or maybe you start in February, but it hasn't got to the point where the trees are actually moving sap up the trunk. That'd be a problem. But I also want to know that as he's done it, he has collected it in a cleanest possible manner and moved it forward. Okay? It's knowing that when it comes off his truck, these hoses and everything else are sterile and clean. That's reducing the uncertainty. Okay? Because if he delivers me crap for sap, I gotta spend a lot of time purifying it and then boiling it down. So why do that? Okay? Now there are processes that are in place now. How do you actually deliver your sap to? You don't have to give away trade secret, but somebody local, right?
Yeah, like half a mile from us.
Do you know what they use for? They use a reverse osmosis system, ultraviolet lights. Yeah. So you can use ultraviolet light, kills any bacteria and other bugs and everything else in there. There's filter systems when it comes off the tree that it's gone through, and every spider that's ever lived its life died in the sap. Trust me, my father-in-law, I'd look at it going, we got another one, and we pour it in, and then we scoop the filter out and put a new filter down. Spiders love sap. I don't know what it is. Why, do you know?
Well, flies love it too.
Flies love it too, so they go in after the flies. I never thought of that. I just know that about every bucket I ever collected from my father-in-law had a spider in it. Anyways, you're gonna filter it. And to help reduce the water content, we're going to use the reverse osmosis system. It takes some of the water out so I can actually boil it down quicker and make the sap. Okay. Then there's a Demetrius press to squeeze it through that actually does a whole other thing. So it's all those things that we want to put in the design of the process to make sure it's going to come out with a product we want. Okay, it's the same thing if you take a look at, well, let's say we're going to build the dorms down here. Okay, 1960. I think they were built in 67. So we want to make sure Smith is the same as Heritage. How do we do that? Well, we want to train the people that work here to go down there and do the same thing. So we're not going to build the 4 crews to build dorms. We're going to build one crew, train them to go build another one, take some of those and have them build the next couple. Okay. So we teach them on the first one. We work our way through the process. Okay. All right. Number 2. So if you don't want to make good products, don't measure it. But if you want to make good products, you need to do it all the time. But you need to figure out what you want to sample and not everything all the time. But basically, you want a never-ending cycle to make sure there's quality. Okay. Number 3, you want to ensure that the process brings you higher quality because your productivity is going to increase, which means you can now outcompete the competition. Okay. So if you were, I want to make sure Ryan's delivering me the best quality sap from the best maple trees, and that somehow he didn't slip in a birch tree. Sap comes out of a birch tree too. All trees have sap, but maples make the better syrup. Okay, at least in my opinion. Some people out west that think a birch tree makes really good syrup. Anybody ever tried birch syrup?
It's like molasses.
Yeah, it's really not all that fun. But I want to make sure that he's not mixing up his trees. So I'm going to hold him accountable, and I want to see how he's deciding which trees he's taking it from. Okay? So he needs to know what a maple tree looks like without its leaves. It could be a silver maple, it could be a sugar maple, it could be a red maple. There's a difference between those 3 trees just in the quality of sap. Okay, we want sugar maple, which has let's see if I get this right, Ryan. It has a S-shaped leaf to the maple leaf. Close.
And higher sugar content, which.
Oh yeah, but you got to be able to identify the tree, and the bark's different than on a silver maple. Okay. So, anyways, if that's good, and I'm getting good quality from him, then I'm going to get more productivity in making sap or syrup, not making sap. Okay. Number 4. So, everybody know who Statistical is over in Governor? They make a lot of steel connections for buildings, and if their management didn't care, then the welders over there could get away with just slapping the crummiest welds on parts and pieces. Okay? They do care, so therefore management's responsible to ensure that the welders have the tools and the skills they need to do that. So they're not just hiring any old welder, they're checking their qualifications. They're ensuring that when that connection weld is made between some connection points for different beams and columns, that it has been looked over, or ultrasound testing methods to actually do it. Don't do destructive testing because that would just ruin the joint. But it's important that management wants to have responsibility for that and actually do something about it. Okay. Okay, I need to go up here on the screen. Okay, so we want everybody that's doing this understands why we're doing it, how the statistics are collected. Does it mean they have to do the math with it? No, but you ought to have every employee understand why they're collecting pieces and samples at a certain point along the way. And then somebody over in engineering is actually doing the math that goes with it. Okay, but if you don't have a welder that understands that every fifth sample of them are going to be sampled for quality control, then you're going to have really crappy results. Okay. Some of you know that spent my first career as an Army officer. One of the crazy things I did, I jump out of perfectly good airplanes. So I have living proof that quality control in the airborne corps is excellent because I'm still here to tell about it and I didn't die on my jumps. Here's how they do quality control there. So, Henry, you are my rigger for my parachute. You pack my chute. You start with a chute that's been used. You lay it out on a table and you check every cable, every strand, every stitch, every bit of canvas that there is with that parachute. It's not really canvas, it's nylon, believe it or not, but they call it canvas. You fold it, you dust it, you clean it. You wrap it up and tuck it inside the bag that it has to deploy from. You attach a static cable which will break away when the airplane pulls at the end of that. Because I'm going that way, the plane's going that way. You will sign off on a little book that you packed it appropriately and did it. It resides in the top left shoulder in a special little secret pocket. And we all rely on the fact that that is 100% quality control, because this is how they check to make sure that the chutes work. I walk in, I'm your commanding officer. Henry, grab the last parachute you packed, be on the flight line in 10 minutes. He's going to jump with the chute he just packed. So if he had a bad day and screwed it up, he's dead. I just eliminated one uncertainty in my process. Okay? So that's how you guarantee quality control. Kill a person. They will do it right. Okay? Or they'll do their best at doing it right. Doesn't mean some chutes don't malfunction. But I will tell you this. There was a cadet in my company that pulled his reserve. And all of a sudden, everybody under the sun was out on the airfield trying to figure out why he pulled his reserve. He panicked. His primary chute was open. He couldn't tell and didn't feel like it was, but he pulled the reserve. The reserve's there when your main parachute does what's called a cigarette roll, and it gets wrapped in itself, entangled, and it's just a straight up and down flag waving in the air. You need a parachute, so you got a reserve. You pull your reserve, there's a major investigation. When he finally admitted he just panicked, everybody stopped and didn't go blame the rigger for it, because guess what? That rigger's name was in that chute, and they knew who did it. So it's that kind of stuff. You want to scare the hell out of people, make them accountable. Okay, but in the real world, management shouldn't threaten people to do things. They want to encourage them to do it. So the best way to encourage them is to teach them why they're doing it. So that's what number 5 is about. Okay. Okay. Number 6, the best way to improve a process is eliminate any common causes. So you're looking for that cause and effect. What's the cause behind the error that came out as the effect? Okay. The other one is sometimes there's just some really special cases and you're not ever going to eliminate them. So isolate them, get them the hell out of the mix. Okay. I'm trying to think of a really good one. And well, common causes would be something like this. So Upstone is making concrete for us. Their little trip lever that's supposed to drop the cement into the process, and then the other trip lever that drops the stone aggregate in, and then we're going to add the sand with it. But one of those three has something stuck in there. They didn't clean the thing. Okay, so a common clause would be poor cleaning, so that the little gate didn't open right, so it didn't pass the same amount of liquid through, or not liquid, the material, right, that it's supposed to. Okay. Okay, another scenario, and it's because it's 5 o'clock and I'm hungry. Chocolate chip cookies. I know it's not quite 5 yet, but we're getting there. Chocolate chip cookies. I want roughly about 6 chocolate chips per cookie that's 2 inches in diameter. Okay, how do I guarantee that? Everybody make chocolate chip cookies? Grandmother should have made you make chocolate chip cookies, right? You mix up the dough, you mix up the eggs, you get all the stuff and the ingredients in there, and then you throw in a cup full of chocolate chips, and you stir like up. Then you scoop it out and put it on the cookie sheet. Do you always get 6 chocolate chips? No. Sometimes you get more. Sometimes you get less. You know, I like that right mix of chocolate chips in my cookie. Okay? How do you make sure it happens that way? Well, it's kind of random in that case. You can't. But could you take out a spoonful of chocolate chip or chocolate dough, cookie dough, and you add in 6 chocolate chips, and then you make a cookie. Then you put it on the cookie sheet. Well, that'd be tedious. But if you're really jerky like I am, you'd make 6 chips in that cookie. Or there's the fact you scoop out the cookie dough, slap it on the thing, and put 6 chocolate chips on top. That'll give you 6 chocolate chips, but it's not inside the cookie, it's all on top. Whereas the chocolate dough runs off the top and onto the cookie sheet. So then you have a really bad cookie. So remember, as I get closer to 5, I'm hungry. And if you're not by now, tough luck. All right, 7. Okay, So really what Deming is famous for is this last line here. Okay? Change the incentive structure. We'll talk about that in a minute. Change your relationship with your suppliers. And the last one is ensure there's training for your employees. And what you're going to train them on happens to be A and B here. 14 points of management and the 7 deadly, well, he calls them diseases, but I remember them as the seven deadly sins of quality control. Okay. I will go over those with you, but I'm not going to do them as something I'm going to write down. I will slip you a piece of paper so you can see them all, so it's accessible, but not put them in here unless I can give you a Word document. See, I can do a Word document, put it in bright space, but I'll give it to you. So you can see them, but I'll go over them, and then I'll give you something so you can actually have something to refer to. Okay. Definitely not worth writing them out. They are worth having, but not literally. Yeah, they're not coming up for a while yet, but when I get there, I will make sure you get them on paper. Okay. All right. So here's a question for you. Nope. Thank you. See, I told you I was going to forget to do that. Okay. This is actually a quote, a question from one of my graduate professors, Farzad Moody. He really explained quality control to me after I got out of the industry and realized that I thought I understood quality control. He started explaining things better. Would you rather have $1,000 a day for 31 days, so you get $31,000 when you're all done, or have a penny on day 1 and double for the next 30 days? So day 2 you get 2 pennies plus the 1. Day 3 you get 4 pennies plus 3 from the days before, so on. See where this is going? So it's an exponential growth. What would you prefer? Go ahead, answer it right. I'm staring at you.
Penny.
You want the penny. Henry? Take the penny. Penny. Because you're all going there.
I don't know. I don't want a bunch of pennies. I might just go with $1,000 a day.
So what if we took all the pennies and once you got $1 worth, we take them into bills?
I don't know which one adds up to more.
Well, that's what you're thinking about here. Okay. So this is the answer. Okay, so the real answer to that is small things add up. Okay. Proves it to you money wise, but you think about some of the other stuff you do. It's that small thing. Did someone actually go clean that gate on the cement that's coming in? Did we buy cement with the right lime mixture to it? That's all small things that add up to, we're all said and done, 10 yards of concrete that we're going to pour that might not be acceptable. Okay, that's a lot of wasted money. Okay. It could be we didn't order the right welding rod for the welders to do the job with, so they used what they had on hand. Made a weaker joint. Small things add up. Would it cost us more to get the right rod and wait a day? Or just go ahead and make a bunch of junk that we can't afford to get rid of? It's a lot of wasted steel. Or if we have to, we regrind that joint out and then start over again. That's time wasted too. So all this stuff's adding up. So any decision you make about quality is always going to be based on what are those small things that are contributing to all this. We really haven't got to root cause analysis yet, but when we do, you're going to see just how potential all that is. Okay. And I'm going up, and you're going up. All right, so we got to have some understanding of numbers here. So, okay. So here's what 99% good means. So this is good. Owen's water beer combination discussion the other day. Taste. Well, if you know that water is going to be bad for 15 minutes during the day, but you don't know when do you take a drink? It's a good one for Dr. Regal. $5,000 incorrect surgical operations. So, anybody been in the hospital lately for anything? Got about a prescription. They always ask you for your name, your birthday, and all that stuff to make sure they're giving you the right prescription. And they also sometimes will ask you what the prescription is. Okay? In the hospital, I had a cataract done in my right eye 3 or 4 years ago. And no joke, they took a little sticky dot and put it over my right eye. So when the surgeon got there and he looked at it and went, right eye. Yes, right eye. I nodded yes. He looked at me, yes. The sticker stayed there until after the surgery. So when I was under, he was still doing the right eye, not the left. The nurse would see it's the right eye. Everybody saw it was the right eye. No way in hell he could have done the left eye. Although he did warn me later. It's like, you're going to have your left eye done. It's like, why don't you do it at the same time then? No. But anyways, they do that. Okay, so there's a bunch more of this, but I'm not going to write them all down. This kind of gets the point across. All right, so 99% good. Is that livable? Ryan, do you want to be the 15-minute drinking guy and get it the wrong 15 minutes? No. Henry, do you want to be the surgical screw up and it's the wrong leg they decide to take off? Yeah. Or even better one, you weren't even going to have an amputation, but they got the patient mixed up and took your good leg off while the other guy that was trying to get a leg taken off didn't. Okay? That would be a screw up.
I went to school with this kid that was born with 6 toes, and so he went to have one of them removed, and they removed the inside toe. So then he had to go back and get the other toe cut off. So then he ended up with 4 toes.
4 toes. That'd be a screw up. Okay, you want to be like that. Okay, do you want to be the construction company that's? Have I talked about the golden staircase down here yet? Do I want to be a construction company that actually has to order the concrete for that and find out of the footers we put down there, they're 18 inches high, 36 inches wide, that we got the wrong concrete mix and now it's buried? No, not whatsoever. Okay. So 99% good sounds like a good number. It's actually not. Okay. We start getting into statistical process control here. I'll show you that we're actually going. Anybody taking statistics? Okay, there's no requirement. Trust me, I'm going to teach you the statistics you need, but I don't want to say something if you have no idea what I'm talking about. So I'll say this again someplace down the road, but there's a mean number when you measure things, and that's usually where all the stuff clusters around. Okay, we want, if you look at it, it's a let's slide up here a bit. So you've all probably heard the bell-shaped curve for there's C's, F, D's, B's, and A's. And by the way, we've never used E's. I never know why. E for everybody gets a chance. D for done. F for failure. C means you got 70% of the coursework. You guys, I hope, will do this. But anyways, we have number of samples over here. And we want most things to fall down through here. We'd like to have it like this. That's the bell-shaped curve. Okay. Turns out across here, when you pull samples, that's 68% of the population of the samples. Okay. That's called first standard deviation. All right. The next one we're going to do crossed here, and that becomes the second standard deviation, but that's only going to put us out to 90. Okay. By the time we get to the third, we're over here and that's our third standard deviation. And that's sigma is what the deviation symbol means. This turns out to be 99%. Okay. But if you take that little graph right there and go back up and realize there's 20,000 pieces of lost mail in an hour, that was 90%. What happened to the 20,000? Well, they didn't get processed. They got misplaced. It got shoved down in a shredder. What if your 20,000, one of the 20,000 was expecting the $1 million check from the lottery? Doesn't matter. It's gone. Okay? So we really go out to much further and further standard deviations, and we usually do it in 6 sigma numbers. And then by the time we get to 6 sigma, we're at 99.9978. Okay, so we really only lose 0.099.978. So we only lose 300,000 samples of mail. Okay, which is a lot less than 20,000. Okay, so we'll go over all that later, but generally that puts that statement into perspective statistically and how we played and do things. Okay. All right. I'll save that for later. We're getting into we're going to start the next lecture with talking about Deming's 14 points. So I definitely got to get you that handout. Okay. All right. Cool. Here's the other thing that's going to go on with life. So later in the semester here, we're going to do a lot more stuff with Excel. And if you got a laptop, you can bring it. I'll demonstrate it, show you how it works. But I'll save that stuff where I'm going to demonstrate on Thursdays, because that's when you're all here. Because actually Luke was here, so that was 6 of you. There's 4 that don't make it on Tuesdays. And then Luke leaves, and I kept looking for new schedule times, and there isn't one. I mean, as much as I tried, there just isn't one. So it's staying at this time, but I'll save the things we demonstrate so everybody's here and sees it. So if you can't make it, Tuesday's the day to skip, because it's going to be recorded anyways. Okay. So we're kind of stuck to this time, and we'll be good. So on that note, I'll see you on Thursday. I'll catch you on the other side of the world.
And this whole stuff